Hello everyone! Welcome to the series on general pathology. In this video, we will start with one of the most fundamental concepts, cellular adaptation. When cells are exposed to stress, they don't simply fail, they adjust to survive. Under normal conditions, cells exist in a stable internal environment called homeostasis. But when that balance is disrupted by increased workload, hormonal signals, or reduced blood supply, cells shift into a new steady state. This process is what we call adaptation, and it follows four main patterns. Let's start with hypertrophy. Hypertrophy is an increase in cell size, typically in tissues that cannot divide. A classic clinical example is left ventricular hypertrophy in a chronic hypertension. Over time, the heart is forced to pump against higher pressure, so the muscle fibers become thicker. At first, this helps maintain cardiac output, but as the wall continues to thicken, it becomes stiff, and the heart starts to struggle with the proper filling. Another familiar example is skeletal muscle growth with resistance training. Hyperplasia. Hyperplasia is an increase in the number of cells, and it only occurs in tissues that are capable of division. A well-known example is the endometrium during menstrual cycle. Under hormonal influence, the cells rapidly proliferate to prepare for possible implantation. Another powerful example is liver regeneration. Even after significant injury or surgical removal of part of the liver, the remaining cells can proliferate and restore the organ's mass. Clinically, this is why partial liver donation is even possible. Now, let's talk about atrophy. Atrophy is when cells shrink and sometimes decrease in number to adapt to reduced demand or limited resources. You can clearly see this in skeletal muscle after prolonged immobilization. When a limb is not used, the muscle gradually loses mass and strength. Another example is the brain during aging, where there is a gradual loss of tissue volume over time. This can affect cognitive function and is something we often correlate clinically with memory decline. Finally, metaplasia. Metaplasia is a more dramatic adaptation in which one adult cell type is replaced by another that is better suited to handle a specific stress. A classic example is in the respiratory tract of smokers. The normal lining is replaced by a more protective type of epithelium that can better tolerate smoke and irritation. While this offers short-term protection, it comes at a cost. The new cells lose important functions like mucus clearance, which increases the risk of infections. Another key example is Barrett's esophagus, where chronic acid reflux leads to a change in the lining of the lower esophagus. The tissue adapts to better tolerate acid exposure, but this change also increases the risk of developing dysplasia and eventually cancer. Overall, cellular adaptation is a powerful survival strategy. It allows cells to adjust, function, and cope with stress in a dynamic way. But this ability is not unlimited. When the stress becomes too severe or persists for too long, the adaptive capacity is overwhelmed. In the next video, we will explore what happens when adaptation fails and cells start to get injured.